All right. So getting into chapter 4. This first lesson is kind of a mishmash of different things. We're going to be talking about some general unit conversion. I'm going to show you my favorite way. There's many different ways of doing unit conversion. My favorite way to do it is by multiplying by fancy ones. It's the way that most science teachers teach it. It may look familiar to you from science class. And then we'll be converting some angle measurements. I need you to freely be able to convert between degrees, like a decimal degrees, like 53.2 degrees, and then degrees, minutes, seconds. So 52 degrees and 18 minutes and 16 seconds, and then radians. Have you guys heard of radians before? It's usually Algebra 2 where they introduce that concept. We'll be thinking a lot in radians in this course. And then we're going to get into some formulas for arc length and sector area. But let's start with unit conversion. So this first example, I want you to picture yourself. You're in a car. You're going 70 miles per hour down Route 5. I would like you to convert that to feet per second. If you already know how to do that, feel free to do your work here. I'm going to walk you through the method that I like to do for this. I like to take my known quantity. I'm going to put it on the left over here. 70 miles per hour, and I need to think about what that means. That is a ratio rate. That means we're doing 70 miles per every 1 hour. So I'm going to set it up like a fraction. That's 70 miles per 1 hour. And basically what I'm going to do is I'm going to multiply this fraction by a bunch of fancy ones. And at the end, I want my final units to be in feet per second. So I left a lot of space in there because I'm going to need a lot of fancy ones to make this work. 70 miles per hour into feet per second. You guys, we've seen fancy ones before. A fancy one is just a fraction. It has the exact same thing on the top and the bottom. But these fancy ones are going to look a little bit different because they're going to have different numbers on the top and bottom, and they'll have different units on the top and bottom. But they should be the same thing. I'll give you an example of a fancy one that we may end up using. Not for this problem, but here's an example of a fancy one. 1 foot over 12 inches is a fancy one. Would you agree that 1 foot and 12 inches are exactly the same thing? So when I divide them, I am going to get 1, okay? So that's what a fancy one means in this context. It's not going to have the same numbers or the same units, but it should be the same thing. My goal is to cancel my unwanted units. I don't want miles per hour. I don't want miles or hours. I'm going to try and cancel those. I'm going to try and end up with feet and second. So let's focus on the distance first. So I'm going to focus on the miles here. And I'm going to make a fancy one that has miles in it someplace. Now, since I don't want miles is in the top. Where should I put my miles in this fancy one? In the top or the bottom? We want it in the bottom because we want miles to cancel out, right? So go ahead and put miles in the bottom there. Always be mindful of what we're trying to get. We're trying to get feet per second. Feet is the distance unit. Does anybody know a conversion rate between feet and miles? I do. Here, let me share it with you. It's 5,280 feet every 1 mile. All right, what have we accomplished there? Well, we haven't really done anything. We took some quantity and we multiplied it by 1. It hasn't changed anything. But what we have done is we've changed the units on it. Since miles match top and bottom, the miles are going to cancel. Now, the 70 and the 1 aren't canceling. It's just the units that cancel. This seems a little bit weird at first, but get used to it. If I were to actually multiply this out right now, I would end up with a new speed, and my new speed would be in feet per hour. Not interested in feet per hour, though. We're interested in feet per second. So let's keep going with this. Let's see if we can multiply to change this hours. So I'm going to multiply And where do I want hours to go on my next fancy one, top or bottom? So hours is in the bottom here, so I want to cancel it, so I'm going to put hours in the top here. And let's do this in a couple steps. Let's go hours to minutes. We could go hours straight to seconds, but let's do hours to minutes. That seems like a more natural progression there. Can you give me some numbers here that would make that work? So this would be equal to 1. 1 hour is equal to 60 minutes. Just do a double check. Is that equal to 1? 1 hour and 60 minutes are the same, right? Quick question, could I have done 2 hours and 120 minutes? Totally. It still would be equal to 1. And we would still come up with the right answer. All right, so now that I got my numbers filled in, let's go ahead and cancel our hours. When we cancel the units, the numbers don't change. We don't cancel the numbers, just the units. And then finally, one more, because right now we're looking at feet per minute, which is close. We want feet per second. We need to cancel minutes. Minutes is in the denominator, so I'm going to put another minutes in my numerator of this fancy one so that they'll cancel. Minutes and seconds. All right, give me some numbers that'll make that equal. 60 minutes is 1 second. 1 second is 60 minutes. 1 minute is 60 seconds. Okay. 1 minute is 60 seconds. Just double check and convince yourself that those two things are the same. Is 1 minute the same as 60 seconds? So we've just multiplied by another copy of 1. Except this is going to allow us to cancel minutes. And now we got what we want, feet per second. So we're good to go. So now we'll just take our calculator, multiply across the top, multiply across the bottom, and then we'll do a little division to finish it out. So 70 times 5280 times 1 times 1, 369,600 feet per 60 times 60 is 3,600 seconds. And we'll divide those to get about that's round to the nearest whole number here, about 103 feet per second. About 103 feet per second. Any questions about that process? How many of you have seen something similar to this in your science classes? Oh yeah, that's awesome. That makes it a little easier. All right, so this is how I'm going to be doing all of our unit conversions in this unit. When we go from degrees to radians and radians to degrees, I'm going to use this same process. It's different than how the book does it. The book would have you memorize 2 different formulas, and that's fine. You can find that information in 4.1 in the book in those green boxes, those 2 formulas. But if you already know how to do it this way, then this is simple. We'll just multiply by a fancy one, and we'll talk about that in a minute. Before we do, though, I have a little public service announcement. Okay, this is about texting and driving. Okay. Think about 103 feet. How far is 103 feet? Is that longer than this classroom? I would say from the end of that hallway, probably 2 or 3 classrooms down. Okay, so I just want you guys to think about 103 feet. When you're driving on the freeway, if you're going the speed limit on I-5, you're going 70 miles per hour. That means you're going 103 feet every second. Okay, so a lot of people think that texting and don't text and drive means don't write text messages while you're driving. But a lot of people think it's okay to just sneak a peek and see what just came in on my text when I was driving. And that's not true. That doesn't count. That is texting while driving. I want you to think about the fact that it takes on average, if you're going to read a text message from somebody, even if all it says is LOL, you're taking your attention off the road for about 2 seconds on average, just to look at it. Okay, that's 206 feet that you are traveling at a fatal speed without any idea of what's going on around you. Okay, that seems to me very dangerous. So just keep that in mind when you're on the freeway, or even when you're not on the freeway and you're only going 35 miles per hour. That's still 50 feet per second. Okay. Every time you take your attention off the road, even to change the radio station, not that anybody listens to the radio anymore, but to change your playlist on your phone, that 1 second that it takes you to do that is time that you are not aware of what's going on the road in front of you. So keep that in mind. All right, so that's enough of my public service announcement. Does anybody have any questions about that process? Multiply by fancy ones. Cancel the units you don't want, keep the units you want. All right, let's get specific into angles now. I want to make sure that you guys are aware of some different types of angle measurements that you may not have seen before. You've heard of a revolution before, right? 1 revolution. If we go all the way around the circle, how many degrees is that? 360 degrees. 1 revolution is 360 degrees. I'm going to put the degree symbol on there. 1 degree is, does anybody know how many minutes are in a degree? If you had to take a guess, what would you guess? 60, because that's how many there are in an hour? That would make sense, right? It's true, yeah. 60 minutes, we abbreviate, when we're talking angles, we abbreviate with a single apostrophe for minutes. So I want you to think about how big a 1 degree angle is for a second. Think of a protractor, right? That's half of a circle. If you just, that 1 degree angle, that's tiny. If I asked you to draw a 1 degree angle, you would have a hard time drawing something that small. A 1 minute angle is 1/60th of that. It's a very, very small angle. And then there's also a thing called a second, which is 1/60th of that. So 1 minute is equal to 60 seconds. These angles are used a lot in astronomy. So when you're measuring how big something is in the sky, you can't measure it in terms of feet or inches. You measure in terms of what's the angle to take you from one side of the moon to the other side of the moon. They're also used to measure angles for launching things into space that need to be really precise, like if we're trying to hit the moon or something further away like Mars. So, and they're used a lot in navigation. This doesn't come up too much. It's mostly just in this first section, but I need you to know what they are because it's kind of classic calculus stuff. So that means that 1 second is equal to 1/60th of a degree. And I wish I'd made this a little bit wider here, which would be 1 second is equal to 1/60th of a minute. What would that be in degrees? 1/3600th of a degree. And 1 minute is 1/60th of a degree. So we're going to convert degrees, minutes, seconds. You'll often see this abbreviated as DMS. I think that's what it says in your textbook. So this is in DMS, and we're going to convert it into degrees as a decimal. So 2 degrees, 31 minutes, and 22 seconds. We're going to convert this into something degrees. Does anybody want to make a rough guess about how big this is going to be? It's going to be something point, and then there's going to be some decimals behind it. Can you tell me what the first number is going to be in front of the decimal? How many whole degrees are we looking at here? There's 2 whole degrees, right? That's 2 point something. 31 minutes is about how much of a degree? Is it about a quarter? Is it about half? Is it about 3/4? It's pretty close to half of a degree, right? Half a degree would be how many minutes? 30. So this is awfully close. This is going to, whatever this number is, it's going to be pretty close to 2.5. Would you agree? going to be pretty close to 2.5. Well, let's do better than that. So all we got to do for this is we're gonna use your calculators for this. I'm going to type in 2 plus. Let's write it down first. Let's write it down, then we'll put it in our calculator. 2 plus, and then I'm going to have a fraction over 60 plus, and then I'm going to have another fraction over 3600, and then I'll hit enter. What's going to go on top of my first fraction here? 31. Because minutes are 1/60th of a degree. And what's going to go on top of my second fraction here? 22, because seconds are 1/3600ths of a degree. So go ahead and type that in, you'll get your answer. Let's round off to 4 decimal places here. Yep, we were right. It is awfully close to 2.5. And let's put our symbol on here for degrees. Pretty straightforward. You're going to have several problems in your assignment where it's going to ask you, it's going to give you degrees, minutes, seconds, say convert it to degrees as a decimal, and this is exactly what you're going to do. You know, some different numbers on top of your 2 fractions here, but other than that, very straightforward. Just type it into your calculator and go. All right, how about going the other direction? 120 degrees, 120.265 degrees into degrees, minutes, seconds. So our final answer here is going to be something degrees, something minutes, something seconds. Do we know what any of those 3 somethings are? We should know what the first one is. What's the first one? That is 120 full degrees, right? Now, does anybody want to make a guess how many minutes we're going to be around here? If you look at this, I'm seeing a 0.26 here. Boy, that's awfully close to 0.25. This is a little bit bigger than a quarter of a degree, right? How many minutes would a quarter of a degree be? 15? I'm going to guess this is 15, maybe 16 though, because it's a little bit bigger. I don't know, 16, 17, who knows? We'll figure it out here. All right, so here's what we do. So here's how I do this. There's different ways to do this, but I'm going to think of this as 120 degrees plus 0.265. Right? 0.265. That's the portion of a degree there. Now, if I want to know how many minutes 0.265 is, I can just take that and multiply it by what? How many minutes are there in a degree again? That's 60. So I'm going to grab my calculator. I'm going to go 0.265 times 60. That's 15.9. So I'd say that's 120 degrees in 15 full minutes, right? Now I'm going to think of that 15.9 as 15 plus 0.9. The 0.9 is like the leftover part, right? And that's what's going to get us our seconds. The 15.9 was in minutes. How many, if I want to convert minutes to seconds, I multiply by 60. There's 60 seconds in a minute. So I'll take that 0.9 and multiply it times 60. Gets me 54. And that's how many seconds we've got. It's 120 degrees, 15 minutes, 54 seconds. Sometimes this last one will have a decimal. If that's the case, then just round it off to 1 or 2 decimal places. So this one's not so straightforward, but basically you take the whole parts, strip that off, that's my number of degrees, and then take what's left over. Okay, those are my leftover degrees. That's not a full degree. We can take this, multiply it by 60. That turns this into minutes. So we had 15.9 minutes. That's 15 whole minutes plus some portion of minutes, so 15 minutes. And then we take the 0.9, that leftover piece, multiply it times 60. That tells us how many seconds are left there. Any questions on that? All right. Let's keep going. Radians. You guys have heard of these, apparently. So 360 degrees is 2 pi radians. Does that sound familiar to you guys? 360 degrees is 2 pi radians. And 180 degrees is pi radians. And do you know why that is? Anybody know why? I want you to imagine, I was going to do this and I totally just forgot about it until now. I want you to imagine a semicircle. If you want to sketch it, you can. That's a pretty good semicircle. Look at me. That's not bad. All right. And imagine that I took a semicircle and I cut a piece of string that was exactly the size of the radius of that semicircle. Actually, I cut a whole bunch of them out, and they're all that same length, r. And I took the first one and I wrapped it around the edge here. It would go to, I don't know, about there-ish. The question is, how many of those little pieces of string would I have to wrap around the edge of this semicircle to get all the way back to here? If you had to guess, how many do you think it would be? Well, I'll tell you. I wish I could show you. It ends up being just a tiny scotch more than 3. Just a tiny, tiny little bit more than 3. Anybody want to guess how much more than 3? 14195. Ooh, who knows their pi? Yeah, it turns out that that's what pi is. Pi is how many radii you have to wrap around a half circle to get there. And if I wanted to do a whole circle, it would be 6 plus a little tiny bit more, about 6.28, which is 2 pi. So that's what a radian is. A 1 radian angle is the angle that you would cut off if you wrapped a 1 radius length piece of string around the edge of a circle. That's what a 1 radian angle is. Okay, it's a little bit bigger than 60 degrees. Wait, yes, it's a little bit bigger than 60. If it was exactly 60, then this would go exactly 3, which would make our lives a lot easier. If pi was 3 instead of 3.14, oh my gosh, the universe would be so much simpler, but it's not. So 1 radian is a thing. Now, oftentimes we're going to express radians in terms of pi, but we can talk about like 1.5 radians. 1.5 radians is about a 90-degree angle, a little bit less. All right, so what I need you to know is that 360 degrees is 2 pi radians, and then this is kind of the key thing for today. 180 degrees is pi radians, and it connects to the circumference of a circle. You guys know this formula, right? I expect that you guys know the formulas for circumference and area at this point. Circumference is 2 pi r. Do we know the area of a circle? Please say yes. Please say yes. It's pi r squared. All right, so let's do some conversions. So we've got 60 degrees. I need you to be able to freely convert between degrees and radians. All right, and the way I'm going to tackle this is the same way that we were doing it a minute ago with miles per hour. I'm going to write down the units that I have. So I'm going to write it as a fraction. Now this isn't a rate, so it's just going to have a 1 on the bottom. That 1 is unitless. So 60 degrees. And I'm just going to multiply it by some fancy 1. And I want to make sure that that fancy 1 has a degree in the bottom of it because I want to cancel that degrees and turn it into radians. Do we know some numbers that will give us an exact same value in the numerator and denominator here with radians and degrees? We sure do. We know that pi radians is the same as 180 degrees. Which allows us to cancel our degrees. We end up with 60 pi over 180. Now we're not going to type this in the calculator for a decimal answer, but I would like you to reduce that fraction for me, please. 60 over 180 turns into 1 over 3. And you can write radians after that, but if you forget to, that's fine, because radians technically is a unitless measure, meaning you don't have to put units after it. All right, so we're just using that same concept that we did before, where this is our fancy one. All right, let's go the opposite direction. Let's take 5 pi over 6. It must be in radians since there's nothing. I know by context it's an angle, and since there's no unit written, it must be radians. So I'm going to write that as a fraction, 5 pi over 6. And when we have a fractional value that's not a rate, the unit goes in the top of the fraction. So 5 pi radians over 6. And we'll multiply that by a fancy 1. We want to set up our fancy 1 so that it's going to cancel radians. So let's get radians in the bottom, degrees in the top. And how many degrees go into how many radians? Let's use 180 and pi again. And then the radians cancel, but that's not all. What else cancels? Pi's cancel also. Hooray! And then we just need to multiply that out and divide. But hey, you don't need a calculator. Stop pushing buttons. All right, look at this. We're going to multiply these things and divide by this, but we can do that in kind of any order we want to. So do the 180 over 6 first. You could do that in your head. What's 180 divided by 6? How many times does 180 go into 6? 30. Times 5 is 150. 180 divided by 6 times 5. Someone should probably check that in their calculator and make sure that that works too, but pretty sure. It's early on a Monday. Well, feels like a Monday. It's Thursday. What a crazy school week, huh? Can you imagine if we had this all the time? It would be great, but we would never remember anything, right? If you had 5 days off every week, like you come back and you'd be like, what did we learn last week again? Yeah, it's tough enough with the gold and blue days, like the block scheduling sometimes, like going from class on a Friday and then you don't have it again until Tuesday. It's a nightmare with testing with my younger students because, you know, we have class and we'll review for a test on Friday and then they have the test on Tuesday. And how many of them do you think actually did any math between Friday and Tuesday? Like a few of them, right? But you guys know better than that. You'd study over the weekend, but yeah, it's brutal. When I taught in places where we had a normal schedule, I would never give a test on a Monday. I usually try to avoid Fridays also, but we just can't afford it with this block schedule. If we start doing that, like we end up losing a whole week because we're trying to change a day of a test. So there's good things about it and there's tough things. Anyways, we digress. All right, 150 degrees. Are we feeling okay about that? Degrees to radians, radians to degrees. If you look in the textbook, they're gonna give you a formula, and the formula is going to tell you either multiply by pi over 180 or by 180 over pi. That's depending on which way you're going. I don't like formulas like that because my brain tends to flip things. So I would probably do it the wrong way about half the time. So I just set up my fancy one. Every time I'll set up my fancy one. It's foolproof. You can't mess it up, right? As long as you're thinking about canceling degrees or canceling radians, you're not going to get the fraction in the wrong order. It's foolproof. Well, whatever works for you. By the way, those of you who do your bonus quizzes, you will actually know these things beforehand, or not beforehand, but by the time you've memorized. So these will be our first two memorization quizzes that you will eventually memorize, that 60 degrees is pi over 3 radians, and that 5 pi over 6 is 150 degrees. You'll know those things. Okay. And there's some tricks to that we'll talk about later on. But for right now, let's just kind of get comfortable thinking in terms of radians and degrees. I'm going to take you through a little exercise in that in a minute, but I want to get through our last little tidbit of the day, which is arc length and sector area. These always show up in the pre-calc textbook, and it's always in this same section at the beginning of our section on the unit circle. They are basically formulas that allow you to find either, if you think about a circle and you think about cutting off a slice of a pie, they either allow you to find the length of the crust or the area of the slice. And if you think about it, both of those things have to do with one of the formulas that we talked about previously. The length of the crust has to do with circumference. And circumference for a circle is pi r, right? When you're looking at this formula in particular, do you see the circumference formula kind of built into it? It's kind of like it's just the circumference times pi over 180, isn't it? Yeah, totally. And this one, actually, the circumference is built into it. It's just that theta, you guys know that's called theta, right? Yes, have you seen that before? Okay. It's just that theta is in radians this time, and it kind of has pi already baked into it. So you'll need to know these two formulas, and then you'll need to know these two formulas as well. I actually, when I do this, I always work them in radians. And if my angle's not in radians, then I'll just convert it into radians. That way I only have to memorize one formula. Sector area, can you see the area formula for a triangle in this one? Or triangle, for a circle in this one also. It's a little bit more clear in the degrees ones, pi r squared times pi over 360 this time. And this one's 1/2 r squared theta. The r squared and then the pi is kind of baked into the theta. So we'll do an example here. This got kind of screwy when I printed this, but a 14.5-inch pizza is cut into 6 slices. How long is the crust on each slice? Sorry about that. A 14-inch pizza is cut into 6 slices. How long is the crust on each slice? So it may be useful to us to make a sketch of a pizza. Oh, that is not my best circle. Well. And when we talk about a pizza, when you go into a pizza place and you order a 14-inch pizza, are you giving them the radius or the diameter of the pizza you want? Anybody work at a pizza place? How big is a 14-inch pizza? Is it this big or is it this big? 14-inch pizza would be this big. They're giving you the diameter. So 14 inches is all the way across. Which means the radius of this pizza is 7. That's useful because if we're looking for an arc length, we need to know r. R appears, no matter which formula we use, r appears in both. We're going to cut this into 6 slices, so let's cut it in half, and then cut it, and cut it, and cut it, and cut it. The other thing that we're going to need to do this problem is theta. What would theta be? How many degrees would theta be? How many degrees all the way around the pizza? 360 degrees all the way around, right? Divided by 6 is theta is 60 degrees. Does anybody have any questions about why theta is 60 degrees? So we could just put 60 into this formula right here, but I'm not going to do that. It would be way easier to just do theta in radians, because isn't this formula much simpler? I love this formula. It's just the radius times the angle. If we had, but this only works if theta is in radians. What would theta be in radians? Tell me this. How big is this angle right here, this half of the pizza here? How big is that? 180 degrees is the same as what in radians? Pi. This half of the pizza is pi, agreed? From here to here, that angle is pi. How many pieces do I need to cut pi into to get our slice here? There's 3 pieces, so the angle in radians is pi over 3. And then we can just plug that into our formula. So if I wanted to find the arc length of this thing, I would go S equals R theta. I'm using R theta because it's simpler. Sorry, you can't see that. No, you can. So S equals R times theta. R was 7. Theta is pi over 3. If I wanted an exact value, it would be 7 pi over 3. This is a word problem, though, so probably we want a decimal. So I'm going to type in 7 pi divided by 3 in my calculator. It comes out to about 7.3 inches. Before we move on, we don't have an example for sector area, so let's just do the area of our slice. We have everything we need. We've got our radius. We've got our angle. Again, I'm going with the radians formula. Good morning. Good morning. We're starting our unit on trig today. Our semester on trig. Heck yeah. Unit circle. Thank you. You too. See ya. All right. Oh, so radius is 7. And then I'm going for the one with the radian version, so I'm using my pi over 3 again. All right, what do we got there? If I turn this into a fraction, we got 1 times 7 times 7 times pi. I think that's 49 pi on the top. And 2 times 1 times 1 times 3 would be 6 on the bottom. 49 pi over 6. That doesn't simplify, but we'll go ahead and turn that into a decimal. Are you guys finding the pi button on your calculators? So as you're working through your assignments and you're going to have some area and some arc length problems, I'll let you guys choose. It's entirely up to you. Do you want to memorize 4 different formulas? If you're good at memorizing things, if that's not an issue for you, then go for it. Memorize all 4 of those. I personally do not have the degrees versions of those formulas memorized. But I got the radians ones memorized because they're much simpler. And I know how to convert degrees into radians. Moreover, a lot of times these problems, you don't really even need to do a conversion because a lot of times it's talking about a portion of a circle. And if you know that I'm dealing with 1/6 of a circle, then you should be able to kind of reason your way into, well, that's 3 slices in half of a circle. Half a circle is pi. Divide that by 3 is pi over 3. And I would encourage you to do that if you can. It's not going to be possible in all of your assignments, but I feel like there's one of them where it's like you're building a racetrack and it's cut into 6 or 10 equal pieces. So then the angle for each of those pieces would be what? If a circle's cut into 10 equal pieces, then how many pieces are there going to be in the top half of the circle? Good morning. So there would be 5 in the top half. There's some notes in the back there, right by that flower pot. There'd be 5, and remind me again, how many radians is it from here to here? How many radians is half a circle? This is one of those things you guys are going to need to know here. That is pi. So how big is each of these slices? Pi over 5. And then you got it in radians. Now we could have gone and figured out that there was 180 degrees divided by 5 is, I don't even know, 36 degrees, and then I could have converted 36 degrees into radians. But doing this is going to help you start thinking in radians, which is going to be super helpful for you. Right now, you guys are super used to degrees. If I tell you to picture a 120-degree angle, you'll probably be able to roughly make a 120-degree angle with your hands. Is that true? Show me what a 120-degree angle would look like with your hands. Yeah, see, look at you guys. You know, it's bigger than 90, it's less than 180, right? But if I asked you to do a 5 pi over 6 angle, that's in radians, how big is a 5 pi over 6 angle? 5 pi over 6, ooh, look at you, you're getting good at this already. 5 pi over 6, is it bigger than pi or less than pi? 5 over 6, 5 pi over 6, is that bigger than 1 pi or less than 1 pi? A little bit less than 1 pi, so it'd be a little bit less than 180 degrees, and it is 150. Nice. Are you here for pre-calc? Okay, awesome. Welcome. All right. So I just want to take you through a quick exercise of thinking in terms of radians. This may help you, it may not. Basically, I need you to, if you're going to do the bonus quizzes, you're going to need to memorize all of your angles between 0 and 360 that are multiples of 30 or 45 degrees, and you need to know those in radians. In fact, before we do this, let me just pull up what the quiz is going to look like. So this will be our first one, and this first quiz won't be for a couple weeks yet, and these are bonus quizzes. Let me pull it up from last year. And I'll be posting up this practice thing. So here are 3 quizzes. You're just going to get a little slip of paper that's going to have all the angles that are multiples of 30 and 45 from 0 to 360. And you'll have it face down on your desk, and I'll say 1, 2, 3, go, and you'll flip it over, and you're going to have like 2 minutes to turn them all into radians. How do you think you could do? 60 degrees is pi over 3, and 45 degrees is pi over 4, and 135 is 3 pi over 4, and 360 is 2 pi, and 210 is 7 pi over 6, and 180 is pi, and 270 is 3 pi over 4 pi over 3. 270 is 3 pi over 2. I'm a little rusty, but you're going to get to the point where you'll be that quick, okay? And then the second memorization quiz will be the opposite. And this is actually usually easier. So you'll be able to go 5 pi over 3. Oh, that's 300 degrees. And 5 pi over 6 is, well, we just talked about that one. That's 150. And 7 pi over 4 is 315 degrees. So you'll just get one of these strips, and you'll have like a minute, I think. You got to be able to do it pretty quickly. Yep. So if you can sort of force yourself to start thinking in terms of these things as you're working your assignments, it'll be helpful to you, especially if you have a problem in your assignment that comes up that is one of those kind of special angles that's a multiple of 45 or 30 or 60 or 90. So let's just go through this. So what we know is, let me make sure I got this, yes. So what we know is that if we cut a circle in half, that this is going to be pi. Half a circle is pi. We're used to thinking of this would be 180 degrees. We're going to be thinking of this as 180 degrees and also pi. We haven't gotten to this yet, but we are going to be talking about the unit circle. The unit circle always starts with 0 on the positive x-axis. So the far right side of the unit circle will always be 0. All right, so no matter what, that's always going to be pi. So I'm going to cut this in half, and I'm going to put 0 there, and I'm going to put pi here also. Now, if I start dividing that up, depending on how we divide it up, then we can get some smaller angles. For example, if I take 180 degrees and I cut it in half, that's a 90-degree angle, right? How much of pi is that angle? That's half of pi. So this would be pi over 2. 90 degrees is pi over 2. And if you start thinking about it as I'm literally cutting a half of a circle in half, I'm cutting pi in half, that's going to go a long ways towards helping you think in terms of radians. Let's go back to our half circle from 0 to pi again. Let's this time cut it into our half circle, or semicircle, let's cut it into 3 equal slices. So now we'd be looking at how many degrees is each of those slices. 180 divided by 3 is, there's 60 degree slices. So in radians, though, it's not going to be 60, it's going to be pi over 3. We literally cut that pi, that semicircle, that half circle, into 3 equal pieces. So that'd be pi over 3. Then this would be 120. We would write this as 2 pi over 3. We're literally just counting around the circle. Eventually, we're going to count around and go 1 pi over 3, 2 pi over 3, 3 pi over 3, 4 pi over 3, 5 pi over 3, and we'll count all the way around, but not today. That's for tomorrow, or Monday. All right, what if we cut it into 4 equal slices? Now each of those slices is a, how many degrees? 45 degree angle, which corresponds to what in radians? Pi over 4. And for our final trick, we'll cut it into 6 equal slices. So I'll cut it into 2 and then cut each of my quarters into 3 pieces. That's the easiest way for me to do it. So 180 degrees cut into 6 equal pieces. Each of those slices would be 30 degrees. And what does 30 degrees correspond to in radians? It's pi over 6. And then from there, the conversion stuff will kind of fall into place. So I challenge you as you're looking through your assignment today, if you run across any angles, any of these special angles, 30, 45, 60, 90, 180, just pause for a moment, challenge yourself to either sketch or think in your head of a circle that's chopped up and see if you can convert that into radians sort of graphically, sort of pictorially like we just did. You're going to be practicing doing it by multiplying by the fancy ones. You'll have some angles where you won't be able to. They're going to throw like a 50-degree angle at you. Okay, and I don't know what 50 degrees is in radians. But these important ones, when you do spot them, if you can start making the association between same thing, when you see pi over 2, I want you to think about, oh, that's just a half circle that's been cut into 2 equal pieces, and that's how big that angle is. If you can start making that connection now, it's going to go a long ways towards what you're going to need to know before the end of this chapter. Okay, and then as you keep going, I'll show you one more trick, and then we'll call it quits for today. Let's say you run into something like 7 pi over 6 radians, and you want to convert that into degrees. I'll show you how I think through this, okay? And you might consider this if it's one of these familiar ones. So these familiar angles are going to have denominators of 6, 4, 3, and 2. So anytime you see a radian that has a denominator of 6, 4, 3, and 2, you should be able to do this. I would think of this as, what's kind of my base angle here? My base angle is pi over 6. I would think of this as 7 times pi over 6. And what is pi over 6 in degrees? That's 7 times 30 degrees, which is how many degrees? 210 degrees. That's it. What would 5 pi over 6 be? 5 pi over 6. Think about the pi over 6. Pi over 6 is how many degrees? Pi over 6 is 30 degrees. Times 5 is 150. Don't anybody shout out an answer, but I want you to try this one on your own. How about 3 pi over 2? So I want you to think about what is pi over 2. You've got your answer keys up at the top of your page. No shame in looking at that right now. You're going to get them memorized eventually. Think about what is pi over 2 and then multiply it times 3. How'd you do? Did you get it? Did you get 270? Woo, how about one more? One more. You guys you're doing so great. You're doing great. How about 5 pi over 3? 5 pi over 3 radians. So kind of think about your root, your pi over 3. Figure out what that is, and then multiply it times 5, and you got it. Did you get it? Did you get 300? Nice. So when I go back and show you this practice quiz again, right? So imagine, just think about this first column here. It doesn't seem so hard now, right? As long as you know what pi over 3, pi over 6, pi over 4, and pi over 2 are, then it's just a matter of multiplying those things. And some of them are 45. So like the 5 pi over 4, 5 pi over 4, you're going to need to know what 45 times 5 is. And those are things that they'll come up so much that you'll remember them. But all right, that's what I got for you guys today. I do not have the Canvas page set up yet, I'm sorry to say, but that will be on my to-do list for